Hi everyone, welcome to this demo video about Ondes, which is a dual video rate oscillator. An oscillator is an essential part of a video synthesis system because it will allow to generate signal that we can use to make two-dimensional patterns. The main difference with a ramp generator like HAMP is that the signal it generates of a fixed frequency. And so the ramp in video will usually be a single cycle either vertically or horizontally, whereas an oscillator like Ondes will have a variable frequency, and so it can create a pattern that has like more or less repetition based on the frequency of the oscillator. Another difference with an oscillator like Animate, which is a low frequency oscillator, is that the frequency range is way higher on Ondes, which will allow to generate like a vertical, horizontal components which can be used to make patterns, whereas something like Animate can only do vertical rate, and so horizontal lines. And another difference is Ondes has a sync input, and so it can be synchronized to the system, whereas Animate is a free running oscillator. Ondes is a dual oscillator, so it has two oscillators into the same module. They share the same features. They both have a manual frequency control at the top, which allows to set the initial frequency of the oscillator. We got frequency modulation CV attenuator, and so it will allow to attenuate and or invert the signal going into the FM, the frequency modulation input. They have a sync switch with three position, which is horizontally synced, vertically synced, and vertical range unsynced, free running. There's also a normalization switch for the amplitude modulation input, in which we'll talk about more later. So for the inputs, each oscillator has a frequency modulation input, which go through the CV attenuator here, amplitude modulation input, which doesn't have any attenuator, and they both have square wave outputs and triangle/sawtooth outputs, which can be amplitude modulated. The square wave cannot be amplitude modulated. And there's also a mix output, which is a mix of the oscillator A and oscillator B triangle sawtooth wave outputs, and so they're mixed together. The idea with this output is that one oscillator is set to horizontal, the other one to vertical, and so at the mix output we get a 2D pattern available. Now let's have a look at the basic operation of Ondes. So I'll get the square wave output from oscillator A into the red inputs of the encoder. So now we got horizontal bars that are scrolling vertically, and they're scrolling because we're set to vertically unsynced mode on the sync switch. As soon as I turn it to vertically synced to the middle position, we now get a modulation that is static. And as I increase the frequency, the number of repetition increase vertically. And if we switch the sync switch to horizontally synced, we now have vertical bars. And the frequency now defines how many times it repeats during a line of a frame, so horizontally. Right now we are monitoring the square wave outputs. That's why we got a signal that goes either from minimum to maximum value with an odd transition in between those two states. If we look at the triangle output now, now we got an oscillation that goes from minimum to maximum in a linear way, and so it generates kind of a gradient going from black to red to black. And let's have a look at the frequency modulation. So we'll look at the signal from oscillator B. So generate those horizontal lines, and let me grab something to split the signal, and so I'll send the second oscillator B, into the frequency modulation of the first oscillator, and I'll also get the oscillator B output into the green input, so we can have a reference of of its frequency. And as soon as I I turn up the CV attenuator, we can see that anytime the green line appears, the red vertical line bends, and if I increase the frequency, we get more repetition, and I can remove the green so we see the red better now. And so, yeah, instead of moving the frequency manually, we can use another signal to do so, and have this chevron kind of thing. And right now we're using the triangle wave, but we can use the square wave. And now, instead of having the frequency slowly changing from minimum to max value, we now jump from one frequency setting to the other. So that's pretty much it for the frequency. We could use also a low frequency oscillator to modulate the frequency, and so now we'll see the frequency slowly increasing and decreasing. Now let's have a look at the amplitude modulation. So the amplitude modulation only affects the triangle sawtooth output, actually only the triangle output, and the sawtooth is made by means of the amplitude modulation. So I'll take the same low frequency oscillator we had before, but using on the AM this time. And as you can see, it slowly fades to mid value and then inverts the signal. I can increase the frequency, and so now we'll start to see the modulation. And so if I remove the modulation, the normalization switches provides a 1 volt a 1 volt reference into the amplitude modulation inputs, and this way it means that we got the triangle output at maximum value. If we send a 0 volt into it, we'll get the same, but the same signal but inverted. Let's have a look at it. If I just touch the ground here, we get it inverted. And the switch can also route the square wave outputs into the amplitude modulation. And if I do it manually with a mini jack, as soon as I plug the square wave, we'll be inverting the triangle wave halfway. And so instead of a triangle output, we now have a sawtooth output. And the normalization switch is here just to allow not having to patch it manually, and so you can just like switch it. And now, instead of having a signal that's slowly increase and decrease and increase and decrease, it does increase to max value, then jumps back to minimum value, increase, jumps back, and so on. Since the sawtooth is made by amplitude modulation, it is a product of modulating the amplitude of the triangle waves with the square wave. It's not possible to modulate the amplitude of this sawtooth besides using another module like cadran after the outputs. And so normalization switch does toggles between triangle wave or sawtooth wave. One thing we haven't seen yet is the mix outputs, and so the mix outputs is the sum of oscillator A and oscillator B, the triangle sawtooth wave outputs. And so now we got a two-dimensional pattern, and since we're using triangle signal, it makes a diamond. And if I switch the horizontally synced oscillator with to a sawtooth, we now have like a more of a like triangle, and we can do the opposite now the vertically synced oscillator is generating a sawtooth. And yeah, I think that's pretty much it for the basic operation of Ondes itself. We can plug the other outputs to have something a little cooler. Now we got different colors and we can switch. Also, as you can see, when no signal is plugged into the FM inputs, it can be used to fine-tune the frequency, and also the range might not be the range of the manual frequency knob might not be enough to just set it as a single cycle, and so you may need to play with the FM knob when nothing is plugged in to be able to reach like a single cycle, like a one you would get with a ramp generator. And let's use animate as a modulation for the amplitude modulation, and using outputs 90 degrees from each other, we get this kind of the shape kind of flipping on itself. Then as we increase the frequency, we'll start to see the pattern again. Can swap the outputs to get a different color tones. We could also use other outputs of animate as a frequency modulation. Previously we've seen how we could use animate as a modulator for Ondes. But now let's see how interesting it can be using ramp or Ondes video rate modulator on the first Ondes. So I'll patch the output of the first Ondes into Solaire, so we get an emphasis on the shapes it generates. So now we got our diamond shape again. We can use other outputs of Ondes into Solaire to get something a little different and more exciting. And one thing I really like to do is using the second Ondes as amplitude modulation. As you can see, we get something a bit more complex already. And let's use the second oscillator from the second Ondes into the modulation from the amplitude modulation of the first Ondes. And right now it's scrolling up and down because this oscillator isn't synced. We can set it to synced again. Can also set it to vertical and make something even more complex. Can switch a little bit on Solaire to get something the different colors. And I like also to use ramp, to use the vertical ramps as a modulation as a frequency modulation on the first Ondes. And so now we get this bend, which is, I think, pretty cool. Can also set the second oscillator to vertical, and we can also maybe use 2D shapes from ramp as amplitude modulation. the effect isn't too obvious, but could also take our low frequency oscillator to give a little bit more animation. Let's get the second oscillator into Solaire as well. Cranking the frequency on animate to add some audio rate modulation. So the vertical scroll is caused by animate now. So now let's get to an even bigger patch. Since on only output triangle waves and square wave, obviously, it's interesting to use it with form, and I don't explain it much into this video, and I recommend watching the dedicated demo video for form. And it's a wave shaper, so we will take a triangle wave signal, or also sawtooth wave as well, and shape it into different wave shapes. We got the sine, anti-sine, expo, log, clipped trapezoid, anti-trapezoid, and asymmetric folding. And I'll get the anti-sine, which I think looks pretty interesting, into Combine, and so I recommend watching the demo video for Combine as well, which is a analog combiner. So we'll take two signals and merge them together in different ways, and let's get the sum output from here into Solaire, and then the output of Solaire into the encoder as always. I mean, we could use the matrix mixer instead, just so we have more control over the color. Check the video about the matrix mix about Matrice, the matrix mixer, if you haven't already. And so the output of the matrix mixer into the encoder. And so yeah, now we're monitoring the anti-sine, and so we got this 4-branch star, and we can use other outputs from Combine into Solaire, so we get something different. Now let's crank up the colors here. And yeah, my favorite patch, as always, with Matrice and Solaire, getting the force outputs as a modulation here, so we get a bit more black. And let's take the asymmetric folding from one of the oscillator. Nice. We can use another shape to see how it looks. Sine wave. So we already have quite a complex possibilities here. We'll get back to patching a second Onde as a amplitude modulation. Then use the ramp as frequency modulation to bend the pattern on itself, kind of. let's unsync that one so we get something slowly modulating. And yeah, we got a cool and complex patch now. Oop. Inverting on matrix to get some other color schemes. Alright, now let's get to the last part of this video, which is using an external video source as a modulation for Ondes. So we now have Entrée to bring an external video signal into the system, and here it's a video playing from the computer. So let's see how it looks. And we can use it as a frequency modulation for the oscillator. And now the frequency of the oscillator changed based on the brightness, the contrast of the external video signal. Maybe it would be easier if I route the mostly unprocessed external video signal into the green inputs. And as we can see, as the external video gets brighter, the frequency of the oscillator increases. Or it can also be the opposite, it decreases as the external video signal gets brighter. It's also interesting to use it on the AM. It's hard to see, oh yeah, because we need to increase the frequency, so I'll remove the green so we can see the effect. And so now the oscillator, the output of the oscillator is inverted based on the external video signal. And so let's do the usual patch with Solaire going into Matrice, my favorite one. And the output of Matrice into the encoder. And the false output of Solaire into the amplitude modulation. And so now we got the pattern generated by Ondes with also amplitude modulation from the external video signal. We can use also the FM. Maybe we set the other oscillator as vertical and yeah, get more modulation. And yeah, we got this like really typical kind of glitch-like effect. So I think you know most of what you need to know about Ondes. Hope you enjoyed the video, and see you in the next demo video.